Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we will discuss about our heterocyclic compound pyrimidine. Pyrimidine, and it is also known as metadiazine. Metadiazine and structure six-member heterocyclic ring containing two nitrogen as heteroatom. Pyrimidines are most important among the three isomeric diazines, ortho, meta and para. All in three, this metadiazine, that is pyrimidine, are most important. Several pyrimidines have been isolated from the nucleic acid hydrolyesters. So it is very important. First of all, we see preparation of pyrimidine and its derivative. Pyrimidine preparation or synthesis of pyrimidine. Several methods have been devised for the preparation of pyrimidines. We have here selected methods. Gabriel, the scientist, Gabriel, in 19 presented pyrimidine from barbituric acid, which in turn can be obtained from urea and malonic acid. So our first synthesis start with urea and malonic acid, COOH, CH2, COOH. This is malonic acid. It reacts with urea, NH2, CONH2. This is urea. So when malonic acid and urea are interacted, then it is with the loss of one water molecules, it converts into barbituric acid. It converts into barbituric acid, CONH, CONH, CH2, CO, or we write down this compound as cyclic hexagonal cyclic situation. This is barbituric acid. This is barbituric, barbi. BARBITURIC, barbituric acid. It undergone by tautomerization. So we write down this compound as barbituric acid. It is also known as urate. It undergoes with phosphorus oxytrichloride. So chlorination takes place and we get derivative of trichloro. Derivative of trichloro. Here bonding. Trichloro derivative of barbituric acid, and it is treated with zinc dust in presence of hot water. In presence of hot water, we get pyrimidine. We get pyrimidine. This is known as Gabriel synthesis. Gabriel, Gabriel synthesis, and it is found in 19. So, when malonic acid and urea are interacted, it converts into barbituric acid. This is followed by phosphorus oxytrichloride. We get chlorine derivative, and then it treated with zinc dust in presence of hot water. Phosphorus oxytrichloride or phosphorus pentachloride PCl5 both give chlorinated product, and this chlorinated product is treated with zinc dust in presence of hot water gives pyrimidine. It is known as Gabriel synthesis. Now we see second compound, second preparation. Whitaker give pyrimidine synthesis by catalytic reductive dechlorination of 2,4-dichloropyrimidine. Whitaker synthesis. Whitaker synthesis in 1953. 2,4-dichloropyrimidine. Dechlorination of 2,4. This is 2 and 4. 2,4-dichloropyrimidine. Dechlorination with the help of palladium carbon and magnesium oxide as reagent. So Whitaker gives pyrimidine. This is very important. Whitaker prepared pyrimidine by catalytic reductive dechlorination of 2,4-dichloropyrimidine, and we have one more preparation for the pyrimidine. So we see number 3, preparation of pyrimidine. Pyrimidine may be obtained from 1133 tetraethoxypropane. I write down 1133 CH2CH O C2H5 twice CH O C2H5 twice. So this is 1133 tetraethoxypropane is treated with formamide HC double bond ONH2. That is formamide in presence of alumina Al2O3 at 200 degrees Celsius. Then it is converted into pyrimidine. So when 1133 tetraethoxypropane and formamide, 1133 tetraethoxypropane and formamide interact in presence of aluminium oxide, alumina, at 200 degrees Celsius gives pyrimidine. Now we see properties of pyrimidine. Melting point of pyrimidine is found 22.5 degrees Celsius and normal temperature, its boiling point is 124 degrees Celsius. Pyrimidine has probably a resonance hybrid, so attack by nucleophilic reactant. Resonance hybrid we also see in pyrimidine. We see the resonance structure of pyrimidine. Resonance structure of pyrimidine. We give numbering 1, 2, 3, 4, 5 and 6. For this numbering, resonance structure, double bond is shifted, then H plus, and for last it is between this and this. So this is the resonance structure of pyrimidine. The resonance of pyrimidine molecule indicates that in pyrimidine position 5 has the greatest electron density. Position 5. This is the position 5. Has the greatest electron density. But attack by electrophilic reagent is difficult as expected since the pyrimidine ring on the wall is deactivated. However, pyridine undergoes electrophilic substitution if an electron releasing group is present in the 2, 4 or 6 position. 2, 4 or 6 position. So these are the resonance structure hybridization of pyrimidine and electrophilic attack by electrophilic substitution. Now we see some more important of pyrimidines. We some point discuss in starting, but I repeat with them. Pyridines are most important isomeric among three isomeric diazines. Several, mainly uracil, thymine, and cytosine. These are three nucleic acids, mainly uracil, thymine, and cytosine. These are isolated from nucleic acid by hydrolyzed state. So, nucleic acid are several constituents of all cell and thus all living matter. Cytosine is found to be present in both type of nucleic acid. Cytosine in both type of nucleic acid, that is RNA and DNA. Ribose nucleic acid and deoxyribose nucleic acid, while uracil is present in RNA. So, cytosine is present in RNA and DNA, while uracil is present in RNA, only RNA, and thymol is only in DNA. So it are very important pyrimidine derivatives. We see the structures of these three our important pyrimidine derivatives. Uracil, this is uracil. Only benzene ring contains one double bond. Thymine, this is thymine, and I write down cytosine, structure of cytosine. These are very important nucleic acid which are derivative of pyrimidines. One more information, in addition to this, pyridine rings is also found in vitamin B1, barbituric acid, that is 2,4, 2,4,6, 2,4,6 trihydroxypyridine, and this is barbituric acid, and several derivatives, as for example veronal, which are used as hypnotics, which are used as hypnotics. 2,4,6 trihydroxypyridine, that is barbituric acid, we discussed in one synthesis. And one very important compound is veronal. So I write down here a structure of veronal for your better knowledge. This is very important derivative of pyrimidines. This is veronal. Verona. So it is very important used as hypnotics. Used in hypnotics. We give two names, barbituric acid and veronal, which are used as hypnotics. So we here complete detailed account of pyrimidines, and now we start or continue with our third azines, that is pyrazine or pyrazine or paradiazine, and then we complete this pyrazine and then we stop today's lecture. So we continue with our next heterocyclic compound, pyrazine. It is also paradiazine. First and 4 nitrogen, which are in benzene ring. So these are the pyrazine. First of all, we see a few pyrazines are natural product. As for example, aspergillic acid, some antibiotics, sulfapyrazine, and other important synthetic drugs, sulfapyrazine, a sulfur drug, and chlorocyclazine, antihistaminic drugs, are the natural product. In last, we see this natural product structure. Pyrazine itself may be prepared from the following two methods. Following two methods. So first of all, we see number 1, chloroacetal. Interaction of chloroacetal, that is CH2Cl bond CHOC2H5 twice. This is chloroacetal, or it is here OC2H5 ethoxy group, so it is 1,1 diethoxy 2 chloroethane. Chloroacetal or 1,1-diethoxy 2-chloroethane is interacted with ammonia NH3. 2 moles of this chloroacetal and ammonia So we get intermediate step NHCH2 CH OC2H5 OC2H5 CH2 CH OC2H5 OC2H5. This is our ethoxy derivative is obtained and and it is treated with HCl H2SO4. So hydrolysis takes place. HCl H2O. So removal of 2 moles of ethanol. It converts into cyclic ring. 6-member cyclic ring. And this position contains OH. OH. This is 1, 2, 3, 4, 5, 6. 2,6 dihydroxy and one nitrogen and one oxygen both are present, then it is known as morpholine. So we obtain 2,6 dihydroxy morpholine. 2,6 dihydroxy morpholine. And this 2,6 dihydroxy morpholine undergone by NH2OH HCl. We get pyrazine. So this is the first preparation for the pyrazine. 1,1 diethoxy 2-chloroethane, 2 moles of this, it is known as chloroacetal, is treated with interacted in ammonia gives derivative, and this derivative undergone by hydrolysis with the help of HCl H2O mixture gives 2,6 dihydroxy morpholine, and it is converted into pyrazine. It is very important synthesis for the pyrazine. Pyrazine is 6-member 2 heteroatom, nitrogen as a 2 heteroatom present in their ring structure. So it is preparation of pyrazine. We have one more synthesis. So second method, we see second method for preparation of pyrazine. Second method. In this method, ethylene diamine, NH2, CH2, CH2, NH2. This is ethylene diamine. And CH2, CH2O. This is ethylene oxide. Is condensation takes place. So we get cyclic type structure, intermediate compound NH, CH2, CH2, OH, NH, CH2, CH2, NH2. Now, dehydration takes place. Removal of H2O. We get in open air, it converts into pyrazine. So, with the help of ethylene diamide and ethylene oxide, gives pyrazine. 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 Now we see some important properties of pyrazine. Pyrazine is solid. Pyrazine is a solid component. So it has melting point and MP of this compound is 55 degrees Celsius. Aromatic character. Aromatic character contains nitrogen, so weak base. According to nitrogen, weak base. Pyrazine is readily reduced by sodium and ethanol to hydropyrazine or piperazine. Hydropyrazine or paparazine. This is hydropyrazine. This is hydropyrazine or piperazine. When this pyridine is react with sodium and ethanol C2H5OH, reduction takes place, so we get hydropyrazine or piperazine. These are very important properties of pyrazine. We stated some few natural compounds which are derivative of pyrazine. So at last we discuss about this natural product of pyrazine. Derivatives of natural occurring compound. A few pyrazine are natural product. So these are the natural product. And I write down some structure. Aspergillic acid used as antibiotics. Aspergillic acid. This is the structure of aspergillic acid. These are very important. CHC6H5. CH3 twice CH CH2 CH2 CH CH3 twice, and here is OS and CH3, CH, CH2, OH, N plus, O minus, CH, C6, H5, CH3. This is aspergillic acid. It is used as antibiotics. It is an antibiotic. Now we see second one more important compound, sulfapyrazine. Sulfapyrazine. This is sulfa drugs. This is also known as antibacterial drugs. All sulfa drugs are known as antibacterial drugs. Sulfapyrazine. And one more antihistaminic drug. We write down structure of antihistaminic drug. This is chlorocyclazine. CYCLIZINE. This is sulfa drugs. And this is antihistaminic drugs. Histamine or anti-allergic drugs. So few pyrazines are natural product. Aspergillic acid used as antibiotic. Important synthetic drugs, sulfapyrazine, sulfa drugs or antibacterial drugs, and chlorocyclazine. Chlorocyclazine, it is known as antihistaminic or anti-allergic drugs. So today we complete 6-member ring heterocyclic compound which has one or more heterocyclic atoms, and in this unit we have remaining only one portion, that is fuse 6-member fuse heterocyclic compound, and we have only two heterocyclic compound. One is quinoline and second is phenyloxazine or phenoxazine or benzoxazine. So we will complete this unit in next lecture. Okay, thank you.